Welcome to this November gathering of the Cloudy Nights EAA team. And perhaps you know a little bit about the history. We'll just tell the 30-second version. And that is back in March, a bunch of us did the Messier marathon together. And we figured that it would be fun to bring some other guys in and do it better next year. But also, I think we just enjoyed the experience. So these monthly gatherings sprang out of that. And we do them in different time zones. Tonight's gathering is focused on the Eastern time zone of North America, but other people in other time zones are welcome to jump in, and we alternate. So maybe there'll be some folks tonight that have live views from their telescope using electronically assisted astronomy techniques, but others can just bring in questions. They can maybe tell what they've been working on. And we typically kind of divide up the time and give like 5 minutes to each guy. Tonight's a little bit special because we have a special speaker coming around 1 hour from now. And the session is really, we usually shoot for 2 hours. And he'll take about a 15-minute section, maybe an hour from now. And during that section, he's going to present some research he's done about a bunch of filters that I think will be interesting to all of us who are interested in filters, that is. And in the process, I think it'll also be just fun to listen to him. He's been doing EAA, Electronically Assisted Astronomy, for 11 years, which just might make him one of the most experienced EAAers among all of us. So I think it'll be fun to hear him. He is Canadian, and it's always great to welcome somebody from our neighbor up north, those of us who are from here in the USA. So we've got several folks online. Let's just kick it off with Gary Hawkins. I think, Gary, you're out in the San Diego area. We're going to start the timer, kind of take 5 or 7 minutes or whatever, and tell us what you've been working on. And I don't know if you have any live images. Go for it, Gary, and welcome everybody else. Gary?
Yeah, sure. So good to see everybody. I'm in San Diego. In fact, I'm actually about 30 miles outside of the city of San Diego in my new QTH. I do actually have a live stream going, which is not my usual live stream, as you'll probably see in a couple of minutes. I can do a screen share. And why don't I just start with the brief equipment? And so I'm going to click screen sharing here, Doug, and hopefully you can.
Sounds great.
This will. Okay. All right. So good. Let's see if I can get the, hopefully you're seeing a picture of my equipment, which is a Celestron C8, fairly old, 1998, coupled with a homemade guide scope. It's got a f6.3 focal reducer on it, ZWO electronic filter wheel that's sitting behind that with 2-inch filters in it, and a 533 MC color camera. Couple of other things to note. I use the Pegasus power box. As you can see, Telrad I find extremely useful, and everything is mounted on a EQ6R. And that's about the view from my back garden if you could, if it was daylight here, which is obviously not. And we have some great views from this new QTH. Unfortunately, before I bought the place, I probably should have done a little bit more research, because it's not really the best location for an observatory. We still get too much marine layer here coming in from the coast. Anyway, my live viewing this evening, let me see if I can work out how to bring up the other, hold on a second here, guys. I got to figure out how I share the other screen. So I think I have to actually stop sharing here.
Sure,
right,
sure.
And then stop sharing and restart.
Right? Is that right?
Sure, go ahead.
Stop share first, yeah.
Okay, right. So, right, what do I do here? I need to, hold on. Okay, so can somebody help me here with the how to stop screen sharing thing?
I should be able to help you with that.
Yeah.
I'm going to stop your sharing.
Brilliant. Okay, so I am going to start screen sharing on another screen.
Okay.
And you guys see that?
Yes, beautiful.
Okay, so we are
Wow, it's so steady.
looking at the moon.
How do you get your air that steady, Gary?
Well, there's a couple of things that are unusual here, right? So firstly, for those of you who are not familiar with the Sharp Cap feature tracking
Oh,
tool, this is actually on, and you can actually see the feature tracking window here.
how about that?
And basically there's two modes. You can either use a center of mass or you can use image features. And I find that the image features tends to work better. So basically I've calibrated the mount to this particular tool, and it's now in tracking mode. And you can see the corrections that are being applied to Sharp Cap to the EQ6R to keep the moon smack in the center of the field of view. And this is a really useful feature, both for viewing the moon and also if you're doing planetary, either EAA or Astro or whatever. It just allows you to make that correction for the errors in the mount and keep the target centered. And so therefore it makes things a little bit easier for the post-processing software on the back end. And even though this is a beta feature, it seems to work quite well. And I don't normally have the moon up, but the reason I'm actually been testing on the moon for the last couple of days is because you may be aware there's an eclipse taking place on Thursday evening, which is a partial eclipse of the moon. So myself and Dave Decker from the San Diego Astronomy Association, plus about 8 other observatories around the world, including Hawaii, and I believe a couple from the East Coast, certainly in Arizona, are providing streams to time and date. And they will then bring those streams together, do a narration. And this is the 3rd time we've actually participated. It's quite a fun event. They have a boatload of viewers. The last time I did this, I think we hit about 100,000 live views and over 1 million views after the event. So kind of fun. So I've been testing this out. And the other odd thing about this is that I'm actually, the light you're seeing coming off the moon here is actually in the oxygen absorption, in the oxygen transmission band. So it's actually a 7 nanometer filter that you're seeing here, and I'm just taking that green channel image and displaying it in monochrome. And that kind of, I found that these narrowband filters, because you're getting so much light off the moon, they do tend to give you a fairly steady image because you don't get the scintillation effect spread across a wide visual range. So that's what you're looking at this evening, just 7 nanometers of bandwidth of data coming in the green channel on the 5x3 camera.
Wow, very impressive. So someone could use this on a comet, for instance. This feature tracking.
I'm not sure it's going to work particularly well on a comet because there's not a lot of light coming off of a comet. So you're probably going to want to gather as much as you can across a wide bandwidth. The use of this filter, which is the Optilong Extreme filter, is particularly well suited to nebulas. But I'm just playing with it because it gives Graham, who's the guy that does the narration on time and date, another talking point to talk to if somebody's using a narrowband filter. The last time I think I did a stream with them, we actually did it in infrared on my stream. So, you know, we just try and give him talking points because
Nice.
3 hours or 4 hours for an eclipse is a long time to keep chatting. And the more points he's got to talk about, the happier he is. So
But I was talking about the feature tracking. We could use the feature tracking on comets.
Again, I don't think it's going to work because it's really designed for relatively bright, big objects.
Planetary.
Robin put this together, the designer of Sharp Cap put this together for planetary imaging primarily, but it's also particularly useful on the moon.
Fantastic. Wow, good stuff. Anyone else have any questions for Gary?
Yeah, that's you said it's Mike here from Spain. That's the
Sure.
Extreme filter. I think that's like 2 or 3 band, I think, isn't it? It's got
It's
HA in it as well.
Yes, it's a 2-band filter. So it's specifically designed for color CMOS cameras, and it's doing the O3 and HL for bands. So it's a 2-band
nice.
filter.
Thinking of getting me one of those. That's good.
Good.
I've actually been quite pleased with it. And when Doug comes back to me on the second image, I'll actually probably do something like the Eagle Nebula or something and bring it up in this 2-band thing so that you can see. The really nice thing about it is it knocks the stars right back. And so that the nebula tends to pop a lot more. The only problem with it is it's an expensive piece of glass.
Mm-hmm.
Do you have the 1 inch or the 1.2 or the 2 inch?
You know, when I set my filter system up, I did it on 2-inch, which probably wasn't, I don't need that for the 553. And so it just makes all my filter purchases more expensive.
Yeah, no, I started and start with 1.25. So far, it's okay.
Yeah, you'll be fine. And I would have been as well. But at the time, I didn't really appreciate that.
Yeah. Cool.
Where are you from originally, Gary? It doesn't sound like a Californian accent there.
No, I'm English. I was born just outside of Bath in southwest England.
Mike,
Okay,
that's awesome. That you were able
that's
awesome you were able to pick out that accent, Mike.
Well, I'm a Brit myself, so
Yes.
you know, and I've lived in California as well. So
Great. You can pick out everything then.
I know a fish out of water when I hear one.
All right.
Well, I'm not necessarily out of water. I'm pretty, I've been here a long time, but I'm trying not to lose the accent.
All right.
No, I was there for 30 years in the States, and people still took like 2 seconds to identify me as a Brit. So
Right.
All right. Gary, is it okay if I drop the image then?
Yeah, absolutely. Switch
right.
over.
Hey, I wonder, Brian, if we could go to you next. Tell us what you've been working on lately, Brian. I don't know if you have an image tonight. Probably not.
No, I just got back in town from being out of town, but I do a little show and tell of what I've been working on lately.
Yeah, go for it.
Is one of these.
You're down in Linden, Tennessee, aren't you?
Yeah, Linden, Tennessee.
Yeah.
So this has been my project lately.
That's awesome.
2004 Questar standard. Got it a couple of weeks ago. Been cleaning it up.
Yeah.
So forth, and
That's
learning how
beautiful.
to use manual setting circles. It's quite fun, actually.
That's a beautiful instrument, and it's very portable. You can take that with you.
Yes, it is. And I got a cool tripod to go with it. A tilt-all aluminum tripod. So
with your blanket there, you could do
I need to turn it on.
Native American presentations or something. I don't know.
Yeah. It's cold. I'm too cheap to turn the heat on, so I got.
What else are you working on? Anything else you're working on, Brian?
Right now, not much. No, just trying to square some gear away. He was talking about Pegasus power box. I had a lot of issues with mine, and in the process of trying to sort them out, I managed to put 12 volts into the wrong port and had to send it back to have it fixed. So I just got it back the other day. So I'm trying to kind of get my setup cobbled back together and working. So
got it. Wow.
Just kind of trying to get things back where it was the last time when it worked.
Well, we're all admiring all of your collections, pocket knives and everything. And your nice homemade shells with the pipes. It's awesome.
Yeah. Thank you.
Brian, if you've got anything else later, just pop back in, okay?
I will. I'll do that. Thank you much, Doug.
I wonder, Ara Jerahian, did I say that name correctly? Would you want to say hello?
Sure. Hi, guys. This is my first time. Thanks for Doug for having me. I am in New England in Maine, up here in on the East Coast, and I was hoping to share something with you guys, but it's actually raining quite heavily right now, so that's not going to happen.
Sorry to hear that.
That's all right. It is Maine. It is what we're used to with the weather here. Let's see. As recently gotten quite a bit into EAA because I'm in the Southern Maine Astronomy Club here. We're trying to do a lot of public outreach. We normally do a lot of public outreach, but we're trying to do a lot of it virtually. And so over the last like 8 or 10 months, put together a rig for the club specifically for EAA. And I've got an observatory here at my home outside that I usually use for my imaging. But I've also done now several virtual EAA star parties for my daughter's class, and then for an extended group of club members, and most recently at the library here, we broadcast a virtual EAA star party and had about 75 people from the community join. And that went really well. And it's really surprising how everyone is just completely enthralled with the stuff that they see through the camera sensor. It's really amazing. I mean, I know even I am, even though I take images of, long exposure images of deep sky targets, it's still incredible to see them come through live. So it's really blown a lot of people's minds away. And now, actually, literally just today, the local library here wants to see if we can do this on a quarterly basis for the community, because they've got, I guess, a lot of good feedback. So that's been pretty awesome. So we're really, really excited. And I kind of wanted to join this call to get maybe some tips and tricks to see how you guys go about doing this stuff. I'm just using my, when I do it myself, I'm using my refractor in the observatory. I've got a, well, when it's reduced, it's an f4.3 refractor. And I have a 294 MC Pro, although the last one I did was monochrome, and I think I will switch to doing it with a color camera. Put the 294 MC Pro when I do it again. I think that adds a little bit more flavor. But yeah, it's pretty incredible showing stuff to people that is, beyond just the moon and Jupiter and stuff that you would do with a telescope and visual viewing. So it's
how long have you been doing this, Ara? Well,
you mean astrophotography in general, or EAA specifically?
Yes.
I started in July of 2018.
Okay.
My family and I moved out from California. We lived in San Francisco and then Oakland. We moved out to Maine just for a change of pace of life, and realized how dark the skies can get here. Even though we have a wicked jet stream above us, and some, large portion of the year is clouded over, but when it's clear, it's a nice dark sky and it's lovely. So
you do, if I remember right, you do live stacking with a thing called Easy Live Stack. How is that different than SharpCap?
Yeah, so I'm glad you asked that. So I found when I do my sessions online, I want to engage with as much with the audience and less with tinkering with the technology. So the easy live stacking that a guy named gosh, I can't actually remember his real name. I can only remember his handle, Dark Archon or whatever. He's part of the Nina development team. Anyway, he wrote the scripts for PixInsight called Easy Processing Suite. One of them is the easy live stacking, and basically you take your first picture, and then, I mean, I can show it, but I don't know how much time we each have. You take your first picture and you set it up to watch that folder, and then whatever other capture system you have that's capturing each image, it'll then pick up, calibrate if you've got your calibration files loaded, but I don't, and then it star lines it and stacks it and updates the display. So that all happens automatically, and I don't really stretches it and all that stuff. So I don't have to tinker with the stretching of SharpCap that I always trying to figure out where the right place is. It just kind of does that automatically. So as I'm talking and describing the image to the audience, it's just constantly updating the image nicely without me having to tinker with it at all.
And is that, would you say you're capturing something then using SharpCap to a folder, and then it's working on the folder, or are you within PixInsight when you're capturing?
It's just watching the folder and picking up a new file that comes in, and it takes about, I downsample the image when I have it set to downsample the image, so it processes it pretty quickly. It takes about 15 seconds for it to process and update the image. So the live stacking, the image captures that I do are usually around 20 seconds long, just to keep it from falling behind. But I'm capturing in a whole different software. So I actually just set up my Nina with all the automated scripting in there to just cycle through and capture. And then I just, after the first image is captured, I set the PixInsight script to monitor that folder, and it then just updates itself. So it's actually pretty hands-free, which is what I was looking to have, right? Something that is live stacking, but not needing me to tinker with it at all.
How interesting. Now, would you tell us again your name? Because we want to pronounce it exactly like you pronounce it.
Well, my first name is easy, Ara. That's all you really have to worry about. But the last name is Armenian. It's Jarahian.
Jarahian. Okay. That's interesting. Well, it's nice to have you from Maine, so we can get somebody up there way in the Northeast.
Indeed.
All right. I bet we come back to you, Ara. Thanks a lot for being with us.
Sure. Thank you, guys.
What about Bill Pratts? Are you with us, Bill? And do you have something to show us or any questions or anything? Maybe Bill doesn't have a mic. He's from Huntington Beach, and I saw him on the participant list a while ago.
I have a mic.
Oh, go ahead, Bill.
Oh, I'm sorry. I stepped away for a minute. I'm running my 3D printer and I like to keep an eye on it.
Of course.
Yeah, we're having a good time here. We just came back from the big event out at Borrego Springs, Southern California, where we enjoyed 4 nights of astronomy.
Wow.
We carried our little AVX mount out there because the CGX mount must have given me a hernia because I'm not going to pick that puppy up again.
Oh, no.
So I just took the little stuff and had a great time. Now we're working on a couple of things here right now. We're going to have an eclipse of the moon on the night of November 18, beginning around 09:30 p.m. California time. Oh, by the way, Mike Huertas, that might be 0500, 0530, so that'd be about 7:30 a.m. your time in Madrid area. I don't think it's going to work. But anyway, good evening to you. We've been to Spain many times. Let's see. So we're trying to figure out the field of view because the night of the 18th, we're trying to decide whether we want to center our scope, and I'll show that to you in a little bit, on the moon and catch Pleiades circling around the moon partway, and also the eclipse. The eclipse begins about, it's really kind of hard to tell. I'm using Sky Safari to measure everything, around 9:45 p.m., 05:45 UTC. And then I have a notebook in the other room. It looks like it completes around 4 a.m. in the morning. I'm not going to stay up that late, so I'm trying to figure out how to automate things. And also, I want a 20-degree field of view at least. If I use my AT80, the field of view is only a couple of degrees. So I made a camera. And years ago, I made all my own cameras. They were real simple things, powered by a Raspberry Pi. I don't know. So this is what I did this time. I found that I still had my little lenses, and by sheer luck, they screw right into the ASI, the ZWO ASI 178 and the 120. And my rig set up outside so I can measure the field of view. I'm hoping, I'm really, I don't know why it doesn't unscrew. No, it's all unscrewing at the same time. Anyway, what this is, I got 2 of these for $10. This particular lens is a 8mm, and f-stop goes down to f1.5. So it probably cost me $5. I was really lucky. It screwed onto the ZWO, and here's the USB cable. And my rig outside is Raspberry Pi running Astroberry. But for this, because
yes,
4 or 5 hours of video would be, it exceeds the size of my SD card. I think I'm going to use All-Sky software. All-Sky software, the All-Sky camera is really a lot of fun. It's a project on GitHub, and I have been running that for 4 or 5 years with this camera, the ASI 178. So because it takes pictures at intervals, 20-second exposures on average all night long, it doesn't fill up the SG chip. So I think I'm going to run it with this and track with the CGX. And I might center on the Pleiades, and it should be really interesting because Jupiter makes about a 270-degree rotation around the Pleiades during that time. So who knows, it's all in fun and games. So that's it. The Raspberry Pi makes some of this stuff easy.
Bill,
Anyway.
you do the most interesting things, and you're 3D printing all at the same time. You've got a three-ring circus going on here.
Yeah, I'm printing the Raspberry Pi. I packaged it in a set, kind of a sandwich, and I don't know if you can see across the room. Well, you can't see; it's too far away. And I'm just 3D printing a stand. So I took a Raspberry Pi, laid it on a piece of whiteboard, put a 16-volt lithium battery that I made, and then the DC to DC converter, and then a 4-port powered USB 2 hub. Packaged it all up real tight. I took that to Borrego this last week, and I ran PhD 2 for guiding, obviously. I didn't try any of the other software. It includes Echos and K-Stars. K-Stars works, but I'm a little frazzled on Echos. So I don't know what to do. A lot of people talk about Indy. That's the newest camera management,
Yes.
but that only runs on a PC. I'm kind of up in the air on PC software. I do use ASICAP. I do use SharpCap. I do use FireCap and Deep Sky Stacker, Auto Stacker, and Registax. They all, you know what they're all for. But when it comes down to camera management, I'm not sure about a Windows platform or a Raspberry Pi platform. Windows platform is very dependable. And you have the full suite of software available to you, just anything you want. Raspberry Pi is rather unique. It's tiny, only draws about 5 watts of power per hour, maybe 6. Okay, give it 6, but you can run all night long on a 5-amp battery. So anyway, and they make these really nice little mini PCs that are about the size of your hand.
Wow.
You're familiar with those.
Bill, what were you in another life? Were you an engineer of some kind?
I have a really hard time explaining to people what I did in my career, but I can just tell you it was very high tech. And I'm proud of it. It was a wonderful career. I started off with NCR Corporation as a computer field engineer, and I stayed in that the large mainframe field for many, many years. While you're in that field, you have the chance to see a lot of technology in depth.
Yes.
So those memories bleed over.
That's
when you're built, I design all my own stuff on 3D designers here.
Wow.
And so the engineering aspects kind of bleed over. I would say the last 10 years, I was really an IT manager.
We'll all remember you now. Next time we have to order something on 3D, we'll remember that you can be our tech. So
this is one. I made this about 5 years ago. That's the sun shield for the camera. I made my antenna rotators, made all the camera adapters. But now that it has DWO, Lumix, and Nikon, I don't need to do that so much anymore.
Right. Well, Bill, it's great to have you with us. And I hope you'll stick around. I wonder, Curtis, now, are you still at the airport, or I saw you next on here. Do you have anything you'd like to share or ask? Or?
Yeah, you caught me at a good time, actually. I just got for a rest stop here. Real quick, what I've been looking at doing is trying to see if we can do a remote setup for EAA. I think you're familiar with those. There's places where you can place a telescope. And most people do this for astrophotography, right? So there's places where you can, get a roll-off set up and, have, 5, 10, whatever number of scopes out there, and a lot of guys go in together. And so that's kind of what I'm looking at, because where I live now, it's really tough for me to, get out and set something up. So that's kind of what I've been looking into lately.
That's great, Chris. I remember you mentioned that you're interested in that, and it sounds like you're going to do it like all out, like at some place that's very dark, for example.
Yeah, exactly. It has to be a place like that. And I figured, so I decided the 12-inch f4 that I have, that's what I'm going to use. out there. And I'm not really sure exactly yet. I haven't decided on the mount. I'm debating whether I should make that a full Dob mount with a 3-axis, basically using a derotator in addition to the alt-as. I haven't decided which way to go with that. But yeah. Now, the other thing I am working on is, in terms of EAA software, I am working on a kind of a deep learning based software that I'm actually in the middle of doing some deep learning boot camp.
Okay.
So that's what I'm looking at doing next. So there's 2 goals I have. One is having, kind of like what was mentioned before, having the software figure out, basically, monitor a folder or get the images and start doing its own stacking, without too much of the setup from a person. And the other thing, so basically, figuring out what's noise and doing that stacking on its own, right?
Got it.
Basically training a deep learning algorithm to do that. The second thing I want to teach it to do is to do what's done manually currently with programs like Registrack and AutoStacker. So those programs, if you're not familiar with them, what they do is you'll go in and you'll take a video of a planet, right, like a bright object, and the video, the frames will have distortions, and it will take some frames, and after going through the steps in there, it will kind of reverse the distortion of the atmosphere and make a nice image of a planet, right? So what I'm going to try to do is train a deep learning algorithm that will automatically do that from video. So
Wow.
It'll take the video frames, and it basically, based on what it's learned, I'm hoping that it can automatically kind of build up a nice image live.
Into AI, artificial intelligence, in a way.
Yes, yeah.
That's
So that's
awesome.
the goal for that one. I think for that, I mean, that's kind of a tricky one, but and the reason I say it's tricky is that the trick is going to be getting it to be able to run something that you could use in the field,
Yeah.
right? So
Right.
so if you have like a bunch of horsepower, sure, it might be able to do it, but and that's what's called inferencing. So I'm trying to do it on something called a Jetson Nano, which is a kind of like a mini board PC, almost like the Raspberry Pi, but it has a little GPU in there, an NVIDIA GPU.
Wow.
And so that's something you could actually run in the field. So that's really the goal, is to get it so that.
Sounds like you're an engineer too.
Yeah, actually, I'm a physicist,
Oh,
and that's my day job as an engineer.
I thought so.
Me too.
That's awesome. Well, thanks so much for reporting back on that. We'll look forward to seeing how that goes. Maybe some of the guys will want to go in with you on that remote observatory if you ever get something set up.
Yeah, I gotta find a place, and
Yeah.
we'll see what's out there.
All right, super. Well, Curtis, stick around if you can. What if we go over to Dave Elder? Dave, I think you were from, Surprise, Arizona. It just sounds like a great place to be from. It's bound to be a great astronomy town, right? It's basically Phoenix, right? I mean, Surprise is basically the outskirts of Phoenix, correct? Dave, did you have to step away? I saw that you were in the participant list, but now I wonder if you stepped away. Okay, we'll come back to Dave. I'm going to put a circle there and come back. I think Don did have to step away. He had wind coming. So Frank, I think that takes us to you. And I think you were going to have some live images for us. What do you got there for us? Frank, if you are speaking, you must be on mute. We are not hearing.
Oh, sorry.
Go ahead.
I just stepped outside because I noticed my my sharp cap stacks started looking weird, and sure enough, there's some some clouds rolling through.
Oh, rats.
That's okay. I was targeting M33, the Triangulum Galaxy, and I noticed some banding, starting to happen, and I just poked my head out the back door, and sure enough, there's clouds out there now. But off to one side, there's some clear sky, so maybe I can focus on something else. But
show us something you've gathered, though. I think you captured a couple of images.
Let's see, share screen. I'm gonna do.
And I think some folks remember what you've got, but
so
others might not.
Yep, I can show you a picture if you're. I think you should be able to see them side by side. That's the live stack of M33 going. That's my back deck. That's got the Evo 8 mounted on a Skywatcher EQ6R Pro. Right now, it's not configured the way you see it with the ASI 533 on the back. I've got it set up with a Hyperstar on the front, so I'm shooting at f1.9. Added a Pegasus pocket box, advanced power box that you see there mounted to the side of the mount, and that's providing power to the camera, the focuser, the scope itself, the mount itself.
You've got the pier extender we see.
And I have an 8-inch pier extension on it as well. Yep.
Nice.
Yep. So, right now toying with the idea of whether or not I want to go and put a guide scope on this thing to maybe extend my exposures, to something, closer to a minute, or I think I can typically get exposures higher without, star trailing or anything like that. It's when it's on the Hyperstar, it's pretty forgiving in terms of, just the speed that it's able to acquire photons at. So,
it's beautiful.
Yeah.
You can see all those star forming.
Yep. You could. So right now I've got the Star Zona filter slider in there. So, and it's got an Optolong L Pro in the drawer. So it's just for a little bit more light pollution. I do have the IDAS NBZ filter as well. I don't typically use that if I'm targeting galaxies, obviously more for the nebula. Been able to use that quite nicely on the Heart and Soul, California, North America nebula. Comes out looking really good.
And Frank's up in Schenectady. So you
Correct.
said that you've got some clouds, but we're glad that you're making this work. How many seconds do you have on this so far? How many frames is that?
Right now, this is 7.5 second exposures at 300 gain, and right now it's been cooking for about just under 7 minutes.
Man, that's fantastic.
Very nice.
You got a very fast scope there, Frank.
Yep.
Yeah.
That's fantastic. Look at those way out at the end of those trailing arms. Look at all that dust being scattered out through there. Wow, great work, Frank. And you must be in some light pollution. What would you guess your Bortle rating is?
Our Bortle rating here in Schenectady is around a 5.
Okay.
To the west of us, we have a dark sky site that the Albany Area Astronomy Club uses. It's a what do they call an arboretum. So it's just a big empty space, nature preserve that's that they let us use. If anyone in the club, I don't belong to it yet, thinking about joining their club, and they go out there quite often, as weather permits.
It's fantastic stuff.
Yep.
Man, we're just mesmerized by your image there, Frank. We really appreciate you seizing the day. I know with your rain, you probably wondered if this was going to work, and look how well it's come through. Good job. Hey,
Yep.
Do you have another image? I think you had something else recorded. I think you had an M42 image.
Oh, yeah, I can throw that up. That's something I saved from earlier this week. I was,
it was beautiful.
going back and forth between planetary and f6.3 and f2. I really like the fact that the flexibility of the SCT and being able to go from like RASA type speeds all the
Yes.
way to F20 or F25 in order to do the long focal length you
stuff.
need for doing the planetary imaging. But
Mhm.
yeah, let me get I'll throw a picture of
Just put that up before you go, because that was
Sure.
beautiful as well. All the colors, the colors popped.
Yep. Let's see, it would probably be this one that I showed you.
Yes. Look how bright that is. Wow.
What filter there?
This is with the same Optolong L Pro.
L Pro? Yeah,
Yep.
very nice.
Yeah, you don't. I mean, Orion comes out just fine without the need for a filter, without any filter in place too. I mean, the NBZ, I really only use that for the really intense HA region type nebula. I used it earlier this summer for the Helix Nebula, and that came out looking really good too.
Now help us learn, Frank, over there to the right. Is that the Running Man Nebula?
Yep.
Is that right?
The Running
Yeah.
Man is here.
Yeah. Mhm.
Yep.
Great.
Maybe, obviously with the 533 being a smaller sensor, this is
Yes.
what it can do with the field of view that the Hyperstar produces. Perhaps being able to do like a montage and be able to eventually go all the way out and grab the horse head and the flame and be able to do
Yes.
collect everything and then tie it all together in one final picture.
That's beautiful.
Yeah.
It's good vision. I hope you follow through with that, Frank,
Yep.
and put it on Cloudy Nights. All right. I'm sure we'll come back to you. And I think you're going to be interested in this talk from this Jim about filters as well, because I know you're good on filters. So we'll come back to you. What about Jason Cropper? Are you with us, Jason? I saw you in the participant list a while ago. Jason, maybe you've had to step away. If you are speaking, you must be muted. I saw you in the list. Jason, last call for Jason. I think you're from Texas. So, all right, we'll come back and try you later. How about John? Do we say Natale or remind me, John?
Can you guys hear me now? I'm trying to get my picture to come up on the screen.
Yes.
And I don't use Zoom much. So maybe you can just hear my voice. But anyway, I'm new to the club. I'm new to astronomy. I just started over the past summer with planetary photography, lots of taking pictures of Jupiter, Saturn. I had a CPC 800 Alt-Az dual fork arm, and I really started to like astronomy or photography. So I sold that, and I'm waiting now to get a EQ6R Pro mount, a 294 camera, and to get started with that, with more photography, more deep sky stuff.
Nice.
Every time I go out in the field, I was just really interested in just Jupiter and Saturn mostly, just being new to astronomy. So
Yes.
I've got lots and lots of those, and they came out fairly well using SharpCap and AutoStacker and Registax. So I had a lot of fun with that. But I should have my new setup probably by May, because everything's on back order. So
Yes.
I've been doing lots and lots of reading, and I've been on Cloudy Nights. I think I probably posted 60 questions on there already. It's like one thing leads to another.
Yep.
But it's been really interesting, and I just wanted to get on tonight to meet some people.
Super.
And see what EAA is all about. And for me, it looks interesting because it looks like something you could go to a star party with and just sort of, have it come to life right there, with other people around, stuff you can share rather than just, processing images the next day and then posting them all. I think
Yes.
the in-person stuff would be probably more valuable. So
You bet.
anyway,
And
I'm just
John-
glad to check in. And I'm sorry I can't get my picture to come up here. I'm just
That's okay.
yeah.
You're
let
from
me,
up in Connecticut, like East Haddam, right?
East Haddam, yes, it's on the Connecticut River, kind of near the shore, near New London.
We have another fellow, Brian McClanahan, that is from up in Connecticut. I think he's from Middletown.
Oh, yeah, I'm right near Middletown. I'm probably 20 minutes from him.
I
Yep.
bet we'll pick up Brian before it's over. I don't think he's on yet, but
Yeah, I just hopped on a couple minutes ago.
Oh, good, Brian. Why don't you go next? You might recognize John from over in East Haddam.
Yeah, that's nearby.
Yeah. Okay. John, anything else you want to share before we go over to Brian?
I don't have a telescope right now, so I don't really have anything to share, but I'm just really happy to be on the forum and meet some people and kind of check in with you guys.
We are glad to have you, brother. Glad you checked in. And Brian, since you're next door neighbor from over in Middletown, Connecticut, go ahead and go next if you've got an image or if you had a question or any kind of gear update you wanted to share.
Sure. I have my scope up. I just got it set up and just started capturing first thing. So let me get it shared.
Nice.
Did that come up or?
It might be working on it, but it's not there yet. Oh,
I think it's coming.
yep,
There we go.
there it is. Yeah.
All right, here we go. All right, so I set up my 8-inch Meade SCT up on a G11 mount. I only have a couple small chip cameras. So this is a Player One Mars C. So the IMX 462 with a UV-IR filter in it because of the IR sensitivity makes the stars really fatten out. And I've got an old Optec Maxfield 0.33 reducer on it. So that pulls the focal length down to somewhere around 715 with the current setup I have. So I just got it polar aligned in sharp cap, swung it over to M1, plate solved, and there we go. So I've got 3 minutes now.
That's great.
So far.
That's great. And what's your border like there in Middletown?
I think it's in the 7 somewhere. It's kind of 7
wow.
area. So
Wow.
it gets pretty bright, yeah.
Yes.
Especially when it gets hazy, it's a lot worse than that. But
Now that 8-inch Meade, how do you like that? I bet that's a great telescope.
yeah, it's a great one. I bought it used. It's an LX90 tube.
Mhm.
It doesn't look great, but I think it performs pretty well.
Yeah, I've heard great things about those. And then are you?
It's not an ACF. It's an old one, just a regular ultra high contrast coated.
Got it. Looks like you're a sharp cap user there.
Yep, I kind of started down the EAA path. I don't know, like in March of this year, and got the pro license right away because it just made everything easy.
That's great. Well, we'll have to get you together with John and Natalie. Since you guys are neighbors, you can exchange information and.
Yeah, that sounds good.
Yeah. I guess the one other thing I was going to bring up is that something I've been playing with, and I think Doug, I saw your posts on this, is the ASCOM remote.
Yes.
So I'm currently have it set up just talking through the device hub to my scope, so that I can have Sky Safari on my phone. So I use that to point. And the new Sky Safari 7 will connect directly into this server. So it will automatically find it on the network and connect into it very easily.
Nice.
So I found that to be very slick so far. There was the Wi-Fi scope that was kind of sort of worked. Then the Alpaca scope came out and that worked pretty well.
Yeah.
And I think Sky Safari 7 is another step forward.
So does this let you skip the Alpaca step altogether?
Yep. The Sky Safari 7 has a native, search function for an Alpaca server.
Wow.
So once that's set up on a computer on the network, it will just find it and you can choose your scope.
It has a native search function for the ASCOM remote server, you mean?
Yep.
Yeah. Okay.
So yeah, you get the server set up, get your scope talking to the server, and then Sky Safari 7 can find it and talk to it.
Sky Safari, it went south for me one additional time while I was on a broadcast with that Alpaca server going. And I was just so fed up with it. I went over to Stellarium and I haven't gone back. But now that you're telling me that I do have Sky Safari 7 installed, I might look at that again, but they don't have it out for the Android yet, do they? It's only iOS.
Yeah, just iOS. Yeah, I think they're working on the Android. They say it's going to be in the next few months, but
in the spring,
who knows what that time will be.
So maybe at that point I'll look at it again. But boy, I'm enjoying Stellarium for now, just because it went south again. Are you experiencing that with the ASCOM direct connection, that it's not losing connectivity as much?
Yeah, I find it to be even more reliable than the Alpaca scope software was, and that was doing pretty well for me. I had a few hiccups here and there, but
it was. I admit. Yeah, boy, Brian, that's great. Well, thanks, and I hope you'll you'll stick around?
Yep, I'm going to stay on for a while.
Okay, good. How about Jonathan Betts? Jonathan, are you on? I saw you on the list. I don't know if you have, looks like you have two connections going. You got your phone and your laptop or something. Surely out of one of those, you can talk to us, Jonathan. If you're muted, we can't hear you. Okay, we'll come back to Jonathan. He might have had to go outside to mess with his scope. Kim, down there in outside of Sydney, what do you got for us tonight, Kim? All the way down in Australia.
A lot of bad weather.
Oh no.
Yeah, we're meant to be running hosting a lunar eclipse event this Friday. It'll be Friday evening our time, and unfortunately the forecast is absolutely terrible. So I'm actually only this morning I wrote to timeanddate.com seeking permission for their live feed. So we have a number of presentations lined up, etc., etc. So I might end up getting some of Gary's feed for all I know. But hey, if anyone wants to be part of that, more than happy to have you on board. Last time we did the lunar eclipse, I think we had about over 2,000 concurrent viewers.
That's fantastic.
And about 50,000 views at some stage. So we got a lot of coverage there. That was great. But anyhow,
do you think most of those are in Australia, or are they all over the world, Kim?
Most of them were actually in Asia, and actually through South Korea as well. We had a request from a couple of their science education facilities to take our stream, which they did. They were clouded. The whole country was clouded out at the time.
Fantastic.
So we did that, and no, it was mainly through Australia and through Asia. Yeah.
Gotcha. That's a beautiful home behind you. Is that your house and your
No, that was our home in Canada when I lived in Canada back in the 90s.
You're just getting nostalgic on us.
Yeah, apparently.
Nice green lawn.
I'll show you quickly. One thing I have been doing is I've finally got around to hooking up my Schmidt-Cassegrain, which I've had for many years. I don't know if you can you see that?
Yes.
Yeah, it's a 1/4 inch Schmidt-Cassegrain, which I've had for, like I said, probably about 12 years or so. And mostly in recent times, I've been using a refractor, 80mm refractor. But I finally got around to hooking this one up with the ASI Air, the 533 camera, the 290. And yes, I use the Powerbox Advance as well, which I find great. And I've taken a few images with it, and I'll just show you. Well, maybe I'll go full screen.
Wow.
It's a bit, so these are my test shots from a few weeks ago, and it's been cloudy ever since. That's just the Gruss triplet, and the stars are a little egg-shaped. I need to sort out what's going on there. And that's just one of the NGC 253. These were just taken from my backyard, Bortle 7, 8. And I was very happy with those. But it was also the first time, believe it or not, I've actually gone and used flat fields. Up to date, I've just completely ignored them and just shot raw images straight out of the 533. So I had some flat field data, and I basically used that and made quite a big difference, actually. Much nicer result. And they're just live stacks, and I just use the ASI Air to live stack, and it does the flat field on the fly. Takes that into account. So I was very happy with that. But yeah, I just need some clear weather now to take that a bit further and iron out some of the bugs. I also shot with this Takahashi a few weeks ago for another live event from the country. We just put out the live stacks out through just a phone network, and that worked really well. That's a 90mm Takahashi, again with a 533 camera at the back. And we were streaming these live across Southern Australia at the time for an event. And that's an image of the lagoon, which was very low in the west at the time. None of these are processed, by the way. It's just straight off the camera. I was quite happy. Oh, and that's with the Extreme filter as well, I might add, which I recommend. Just does produce some very nice results. That's the Optolong Extreme. And the iconic Horsehead Nebula and Flame Nebula, that was very low on the east. We just shot that. That was just a 3-minute single shot, I think, right at the end of the night as well, finishing up. Very happy with that, just from given what we had. Yeah, so we have this lunar eclipse event coming up on Friday, and we're kind of stuck for. Normally we'd have a few telescopes, but this time we're all clouded out, so we're just looking for other opportunities to stream, and that's basically what the weather forecast is for later this week. That's Australia through the middle there, and there's this huge band through the southern part of the country, and we're not going to escape that. And more of it coming down from the tropics up north, so we need your help. So apart from that, we also had we had one of these outreach events for our winter star party back in August. And the idea behind it was we would actually do EAA, and I guess you probably have seen this before.
Yes.
But the idea was we would have telescopes that we connected to iPads or iPhones, and it would be projected, and people would actually stand around and watch it. That was the theory, and we actually had a multiple telescope option set up on the day with multiple Wi-Fis flying around. And in the end, the Wi-Fi actually fell down on us and caused a whole lot of technical issues. So the upshot from that was, while this worked really well and provided quite an impact for the people that were watching it, we decided in future, given the lessons learned, we would actually run it a little bit differently. We'd still have one very large projection screen, but we'll have multiple smaller screens at each of the telescopes where people can look at the images rather than having to look through an eyepiece. They can still look through an eyepiece, but having an image on display, people were just stunned with what they saw. Most people didn't believe what they were seeing. They instantly want to know where it was in the sky, so you had to point it out with a green laser. And even then, obviously, they couldn't see it. But it was quite a successful event. But this is kind of the layout on the day, and this is where we're just streaming everything to one projector, and that's where it fell apart. But so in future, we'll have screens against these telescopes here, just small computer screens, and people can watch them rather than relying on everything going through one projector.
Nice.
So that's the plan in future. The moon selfies were really popular with the kids, projecting the moon live, and they were there taking images of themselves with the moon in the background. They love that. That was they really got into that. So that's all I really had to talk to tonight. So hopefully that's of interest to people. But yeah, EAA is wonderful for outreach, which is what we're using it for.
Kim, you do such a great job raising the bar on the promotion of your events, and it's quite obvious that you're reaping the harvest from it because you're having all this interest. So I hope you'll stick around. We'll come back to you. Thanks so much.
We're learning as we go, and I think everyone is. And it's
we all are.
We want to share that as much as possible too.
Right.
Kim, quick question.
Yeah.
I remember last time I asked you this question. Any recommendations on a projector? Because that's something I've been thinking of doing.
Yeah, I remember the question, and I've looked, and I've not found anything other than the advice is do not use a TV screen, use a computer monitor, because the colors are more true to life and accurate, whereas TV screens have a different color gamut. And I've noticed that where we have used TV screens, the colors just don't look right. On your iPad, they look right. On the computer, they look right, but on the TV screens, they don't.
Yeah, and I've got one up here in front of me here, and I see that. Yeah.
But no, we don't have a solution for that. I've seen some portable computer monitors. I think they come out of the gaming industry.
Yeah.
You can attach to the side, and I think someone was using one last time and recommended it, but I haven't actually personally investigated those.
No, that's my goal, is to project onto the side of the house here. You know.
Yeah, well, we're projecting on the side of an observatory dome. If you picked up on that.
Yes.
And it's good use for an observatory, right? That worked really well, but the colors were exaggerated and weird, and we just didn't have the time to correct.
Okay, thanks.
Yeah,
So I don't have an answer for you, Mark. Yeah.
I have to agree with Kim there. I use a 40-inch TV for outreach purposes, and getting the color balance correct is really tricky on a TV screen.
You know, if you're trying
it does give you a good impact. I mean,
Absolutely.
you can get a lot of people around a 40-inch screen.
Have you guys tried an OLED? They seem to have better color.
Okay.
No, I have not. I mean, typically with this stuff, right, it tends to be the stuff that you're not using that you tend to repurpose for astronomy. And unfortunately, my LCD screen that I'm using I mean, it's great, but it does take some tweaking to get the color balance right.
These Casio projectors, I don't know if you guys have ever looked, they're so inexpensive, but they're so bright. It might be worth looking, and you can get those on eBay sometimes for $200, the used Casio projectors. So you just might try that. It's the same company that makes like the cheaper pianos. They make these cheaper projectors, but they are like bulletproof. They last forever, and they're extremely bright if you invest in them. So might check that out. All right, Lance, let's come over to you from Idaho. What do you got going on tonight, and what kinds of questions, or do you have an image going, Lance? I see you in the list there, so take a second and get unmuted. Lance, are you with us? You have if I remember right, you have a mead, a large mead. Maybe he's had to step out to scope. We'll come back to him as well. Michael Owen is with us tonight. I just want to say, Gary, you will remember the Michael Owen of football days over in England.
I would. Yes.
Yeah, Michael, is the same?
Not my
Michael?
favorite football star, but yes, I would remember.
Yeah, Michael
I am not the same one. Can you hear me?
Oh, yes, we can hear you fine, Michael.
Yeah, no, different Michael Owen.
Okay.
I did once upon a time in grad school get email for that Michael Owen.
That's great.
Strange that they would think that Michael Owen, the football star, would work in the theoretical astrophysics group at NC State. But yeah, no, this is my first time here, and really appreciate it. This is very fun. I love hearing you guys talk. I seem to be the only one that is sitting outside in the cold. Everybody has a nice remote setup from inside their house, and I'm kind of jealous.
No, I'm outside as well, if that makes you feel any better.
Yeah,
Michael,
if it's any consolation, if I had a scope up, Mike, I'd be outside too.
Yeah.
So
It's just that Gary's in San Diego, so he doesn't count.
that doesn't count, Gary.
Yeah, it's not cold here in Southern California. 72.
it's like 34 here. So yeah.
Well, I'm in Florida, but it's northern Florida. So
Okay.
and I
That's
can
what's
have,
like 65.
have a live scope here that I can
Go ahead, Michael.
share.
Let us see.
Tweaking around with my histogram and sharp cap. We have a pretty bright moon up there.
Yep.
Yes.
So
we knew that we would, but we chose this weekend so that we wouldn't have to deal with the time shifting. That's the problem.
let me know if you can see
beautiful.
my screen.
Yeah, it's beautiful. That's not M13, is it?
It is not M13. M13 has already set. It is M15.
M15.
Yeah.
Figured that a globular cluster would be a nice bright thing.
It's beautiful. And what are you using? Remind us of what scope you have, Michael.
I have a 1985 C8. It's a very interesting scope. It's extremely unique. It's a white tube C8, which a lot of people will tell you don't exist. They do. I have one. Almost all of the scopes of that era were orange and then black, and none of them were white, except for there was a company called Optica out of Denver, Colorado, that in 1984 ordered 100 white tube C8s, and I have
No
one
way.
of them.
No way.
Yep. And
That's awesome.
It's awesome. I have it reduced with the Celestron f6.3 reducer corrector. Mine measures out at 6.5. I probably have the backspacing a little bit wrong, but with my chip size, it doesn't seem to hurt it, so I don't mess with it. I'm using the ASI 183 MC, not the Pro version. It's uncooled. I've been thinking about getting a cooled camera. I was looking at the 294. I was looking at the 183 MC Pro cooled version, the 533. I don't know. I figure I should milk every bit of enjoyment out of this camera before I move on. And it's sitting on a C-Gem mount, which is the mount for my 1100 HD, Edge HD, which I am not running tonight because the seeing is kind of poor, and I really don't know that the C-Gem is enough mount for that scope, but it takes wicked beautiful pictures of the moon. And I have a question.
Yes.
Who knows anything about the new background subtraction in SharpCap?
Somebody will.
Because my question is, if I'm live stacking deep sky like this, and I turn on background subtraction, is it going to try to subtract the background from the stack, or is it going to try to subtract the background from the individual frames?
I'm going to guess Gary's worked on that.
Because
I think it's trying to do the background on the individual frames.
yeah, that's what I was afraid of. That seems dangerous. There's a lot. The signal to noise ratio is way lower in the individual frames, so that's interesting. Maybe I'll pop on.
I seem to remember there was a question on that on the SharpCap forum, and it was causing problems.
I might pop over to the forum and ask about that, because the background, the gradient removal tools that are available in some of the processing programs are fantastic, and I would love to be able to do that live, but I have not had much luck with the background subtraction since it was introduced in SharpCap. So maybe it's probably user error. It's always user error. So
for what it's worth, on my M33 image that I shared earlier, I did have the blended offset turned on. It hasn't. I mean, there's times when I use it and times when I don't. I can't say I see a vast improvement between having it enabled or disabled, or the other, the simple offset setting. Minimal change, to be quite honest.
That's Frank, right?
Yep.
Yeah, I was the same, Frank. I used it for the first time the other night, and I didn't notice a huge difference either. And I was using the blended as well.
I mean, it may, the most difference I see in terms of, if there's a section of the sky that of the field of view that's got some, if you want to clean it up, I guess there's some minor effects that it helps out with that, but
awesome.
Nothing to write home about.
Awesome. Well, thanks so much. I really appreciate you being willing to share. And it's too bad you're not the footballer. That would be a great story if we could say we had the footballer on as well. But well, Michael, we'll come back to you. I hope you can stick around. And that's a beautiful image.
Yes,
thanks a lot for having your scope running. Hey, we're going to skip over to our special guest now. Jim Thompson works out of Ottawa. He is the fellow that you might have seen recently in Cloudy Nights, who posted the tremendous thread. Do you mind, Michael, if I go ahead and drop your sharing then? Yeah. Oh, there you go. Jim, if you would, we are eager to hear you share how you came about doing this this special filter research project that you did. And could you just tell a little bit about your journey over the last, if I'm not mistaken, like 11 years in EAA, and most of us have started in the last 1 to 5, but you've got double that. Kind of walk us through your journey, take 15 minutes or so, and speak to us about those filters as well, because we found it to be a very in-depth research project, and we're eager to learn all we can from you, brother. So welcome.
Okay, welcome. Is my mic's working all right?
Yes, working great.
Okay, I did throw a couple of slides together. So everybody can see
yes,
that?
Perfectly,
all right.
Perfectly.
We're good.
All right, so Well, thank you for inviting me this evening. I had no idea that this group even existed. It's kind of interesting because locally in the Ottawa area, we have a similar Zoom-based group that meets whenever there's a forecast for good weather. We set a meeting date and we all observe together. It's kind of a good camaraderie, you know, hanging out, sharing views of each other's telescope, that sort of thing. So it's interesting to know that we are not the pioneers of that it seems like we are part of a much larger group.
You might have been the pioneers. We don't know, but we're glad you're doing it too.
We started it pretty much right when things started to lock down in 2020. So maybe about a year and a half ago.
Yeah. That's before we started.
So just a few slides talking about who the heck this guy, Jim Thompson, is. So I'm an aerospace engineer by trade. I went to school here on Carleton University, got my master's degree in aerospace engineering. And since graduation, I've worked for a military company here in town that designs and builds exhaust systems for ships and aircraft. As mentioned, I live in Ottawa, and by in Ottawa, I mean right in the downtown part of the city where the skies are horrible, probably a Bortle 9+. On a good night, I can see maybe a magnitude 3 star, if I'm lucky.
Oh, wow.
So I started doing EAA back in 2010. The first camera that I ever purchased was a Mellencam Extreme, and I did a lot of work with that camera. A lot of my early filter testing was done with that camera. Now, what attracted me to filter research, it really began right at the start of my journey into EAA. Because I'm under such a heavy light polluted sky, it was obvious I needed to use some kind of a filter to try to cut through the gloom. And when I started looking around online, I found that there were just way too many filters to choose from. And all of the offerings from different manufacturers were inconsistently explained. There were no comparisons to know how one filter performs relative to another. And that left me really scratching my head as to what filter should I buy for my application. Because if you try to talk to anybody at any of these retailers, they don't have a clue. They just say, oh, this is the best filter you should use. And then you call another supplier and they say, oh, no, you need to use this filter. This is the best filter to use. So my engineering background drove me towards figuring this problem out for myself. We can talk a little bit more about that later. Just kind of bring everybody up to speed with kind of stuff that I'm working with here in the city. I have a range of telescope sizes, 10-inch RC, 6-inch Schmidt that I use normally when I'm up at the cottage, a 4-inch William Optics refractor, which I really like, an 80 millimeter refractor that I usually use at the cottage, a smaller refractor, 67 mil. And then recently I have gotten into mini refractors. So the Evo Guide 50 was the first one that I bought. That was last summer, I got that one. And then just this past, actually the Evo Guide I've had for two summers ago. The ultra wide I bought last summer. And I'm having tons of fun doing wide view EAA with those two tiny little refractors. And I also have a bucket full of camera lenses that I've played with over the years. My main mount here in the backyard is an EQ8. It's set on a concrete pier with a flip down doghouse to protect it from the elements, so it stays outside along with the scopes. When I travel to the cottage, I take an LX65. Not a lot of people use that mount, and it's too bad because it's actually pretty versatile. It's Alt-Az, but it has two shoes on it. You can take two scopes at the same time. Works really well. I'm very happy with it. And then finally, for backpacking or camping, I have an Ioptron Cube Pro, which works really well. Cameras, I've got a lot of cameras. I have at some point in time used pretty much every single camera made by Mellencam. The ones that I currently have in my possession include the Extreme Color that I had from the very beginning, an Exterminator Monochrome, Junior Pro, Micro, SSIC, Universe, and then a bunch of the DS series. With the DS432 Monochrome being my current camera that I use all the time. Like for observing now, I use the DS432 Monochrome and the ASI 294 MC Pro as my color camera. Those are my two favorite cameras. ZWO, I have a mitt full of their cameras as well, mostly because I also do a lot of solar system imaging, a lot of lunar photography and planets. And so I've experimented with different cameras for that purpose. And unfortunately, there isn't one camera that works well for everything. So the 290 works really well with my H alpha. The 183 works really well when I do lunar imaging. The 462 is one that I just got recently. It seems to work pretty well for planets. So kind of a mix and match there. And then I did a lot of research probably 5 or 6 years ago now, comparing cameras in a historical sense, looking at CCD cameras versus what was new at the time, CMOS cameras. And I did a bunch of testing comparing how quickly you can generate a usable image with different types of cameras. So that's part of the reason I have so many Mellencams, is because of that testing. But I also have cameras that go all the way back into the early 90s that I've had donated or found online. Like I have a Stella Cam here. I've got a bunch of different cameras kicking around. So I've got quite a library of cameras to choose from. And filters, I've got a lot of filters. A veritable drawer full. But primarily, I use the NBZ by EDIS and the Optolong L Extreme are the two main filters I'm using these days. So that's just an overview of who I am. Now, if you have any interest in reading up on my work, you can go to my website. There's a bunch of test reports at the link here. There's also some research papers that I've written that are more kind of general. There isn't really any testing discussed in them. I've also written more than a dozen magazine articles, mostly for Astronomy Technology Today. So I have copies of those online you can check out if you like. And then just recently I put all of that material under ResearchGate, and it seems to actually have been a good call, because I started getting messages from people all of a sudden from all over the world. So it seems to be a good venue. If you have material you like to publish and get out into the public, ResearchGate, it's free. It's a good spot to put your stuff. So I was going to primarily talk about the EDIS filter test report that was recently posted, but I am happy to answer questions about any of the filters testing that I've done. I've tested pretty much every Optolong filter made, including a new filter that hasn't been released that I can tell you about if you guys are interested in it. I also did a pretty in-depth study of multiband filters about a year ago, which was sort of the start of the whole dual narrowband filters, which are a fairly new type of filter on the market. They're only a couple of years old. So I'm going to go now to a test report. And just, I'm going to kind of quickly step through it and go to the main points. But if anybody has any questions, just go ahead and speak up. So my reason for this particular test report was that I find this company is a little bit underappreciated. There hasn't been a lot of discussion about their filters. I don't know why that is. Maybe it's just within the circles that I travel in, you know, the EAA circles. Maybe they're more popular with DSLR users, but I felt it important to educate people on the type of filters that they produce, because they're a really good company, in my opinion. All of the filters that I've encountered from them over the years, they've been very high quality, very high performance, and a little bit sort of cutting edge. They've made a lot of developments, kind of leading the market. So, for example, this is a photo of all of the filters that I had for testing. The EDIS LPS P2. Get my annotate tool here. So this filter, that's the first filter that I ever owned. I bought it, you know, shortly after I got into EAA, and I was exploring, you know, what are the kinds of filters that I need to be able to view under heavy light pollution. And even then, the quality of the filters was very high, and I was very pleased with that filter. But as the light pollution got worse in the Ottawa area, I needed to kind of narrow in on the band pass and cut out more light pollution. So my interest kind of evolved. But over time, this LPS P2 has evolved, and now they have the LPS P3, which is a further improvement. So every time they come out with a new filter, they're always trying to improve it. You know, the percentage transmissivity numbers, they're bumping them up closer and closer to 100%. They're using the feedback from their customers saying, oh, you know, I wish, you know, you move the bands over to the left a little bit or something. And they're trying to incorporate all these things. So I really appreciate the effort that they're making. They're not just cranking out filters to try to get the most money they can. So my impetus for doing this test was, let's let people know who this company is and what they have to offer. So these were the particular filters that I tested. It's only a fraction of what they have available. There's a summary table down here. So a lot of these filters aren't available for sale new, but you can find them used online. That's why I included all of them in my comparison, because some of these filters, they're still available used out there in the market. So they have mostly two families of filters: the light pollution suppression and the nebula contrast booster. And the other sort of miscellaneous filters at the bottom of the list, they could be put into one of the other two categories because they're very similar in performance. So the testing I did was sort of two types of testing. The first set of tests I did on a bench spectrometer. I'm just going to scroll down to the appendix where I show a picture of it. So I built this this ugly looking box here. Is my light source. There's 3 different types of light inside to try to generate as flat a light emission as I could get. There's an optical fiber leading to a spectrometer. It's a handy little gizmo, USB driven, has a easy to use piece of software that comes with it. And then I put the filter in between the optical fiber and the light source and measure the spectrum. Now this particular rig, it's a recent modification that I made. Gotta zoom in on it here. So the filter sits on a little clear plastic tray, and this 1/4-20 bolt is used to, in a controlled manner, change the tilt of the filter relative to the light. And I added this feature to the test rig to be able to evaluate how filters perform at fast F ratios. So that's a fairly recent development, and probably what most of the discussion has been online lately, with people using faster and faster optics. So the outcome of using that spectrometer is a series of measured spectrums for all of the filters that were tested. Where I didn't have a filter to test, I looked online for available sources. For example, this German fellow, Noffel, he had a bunch of measurements that he had done with a spectrometer, so I borrowed his data. But you can see what I mean here for the LPSP series, the progression of the filter's design over time, where in the H alpha band, the P1, it only had around 95% transmissivity, and each version of the filter after that has pushed that higher and higher. So now they're very close to 100% transmission of H alpha. So that's the kind of innovation that really impresses me about a company. So all of the spectrums are either measured or got off of the website. So these other D1 and D3 I got from the EDIS website. The V3 and V4 are hard to find out there, but they're still around. And probably the filters of most interest are these nebula boosters. So with this measured spectrum data, I was able to do stuff like go in and find percent transmission at bands of interest, and calculate bandwidths. I'm also able to calculate a prediction of how well each of the filters do against light pollution. So there's a lot of information on it in this particular graph, but I'll try to break it down. So one of the things that I have sort of created out of nothing, basically, is a way of comparing how one filter will perform relative to another on a particular type of deep sky object. It's all done by calculation. It uses the spectrum data that I measured or get off the internet, uses the spectrum of the camera, and it uses the spectrum of the light pollution. And using all of those things, a bunch of calculations comes up with an estimate of how much the contrast can be improved by using the filter. So this particular plot is for a really awful light polluted sky, i.e. my backyard. And it is using a back illuminated CMOS camera. The red circles, which sort of follow along the top of the curve, are the performance of each filter when observing a bright type of nebula. So that would be like M27 or M76, something that's rich in O3 and relatively bright. The green diamonds are for a dim type emission nebula. So like the North American Nebula or the Rosette or something like that, that is primarily hydrogen alpha emission. And then sort of jumbled up below are the green squares for galaxy. In particular, I chose the spectrum from M51. The purple triangles are for a reflection nebula. I think it was the Pleiades that I chose, or the reflection nebula around the Pleiades. And then the orange upside down rectangle or triangle is a comet. I think it was Hyakutake. Anyway, so the objective on this plot is to be as high on it as possible, so the highest increase in contrast, but also to have the highest luminous transmissivity, so letting the highest percentage of light through. And you'll notice that there is a noticeable trend in the data. So all the LPS family filters are sort of around the 100% increase in contrast range on nebulae. And as the luminous transmissivity goes down, there's a slight increase in the contrast. But then when you jump to dual bandpass type filters, so the more narrow band filters, there's quite a jump up in the ability of the filter to improve contrast. As the luminous transmissivity goes down, the contrast goes up. And that corresponds also to the width of the bandpass. So the NBZ, the NBX, they have the narrowest pass band width of all of the filters that IDIS makes, at least in the multiband. They have some single narrowband filters now, but I won't talk about them tonight. So this is the sort of data that I was able to generate from just the bench test measurements of each of the filters. A little less clear. Oh, there's somebody at the door. If you excuse me for just a second.
Sure, we're still trying to figure
I'm
out
on door
what is
duty.
Transmissivity. I just want to say smart sounding words like that. I just want to say, well, Frank, what do you think of the luminance transmissivity of this? I mean, it just sounds so smart. When I grow up, that's what I want to do. I don't know about you guys, but I find this very interesting that there is a way to calibrate and measure mathematically. So we know what we're buying. Jim, back to you. I was just stalling while you were at the door. Go ahead.
Now you'll note that on galaxies, reflection nebula, and comets, the amount of contrast improvement that's predicted is not all that great. And that is a reality of trying to view these types of objects in a light polluted environment. Filters can help a little bit. It's not as dramatic as on a nebulae, but you can get a little bit of an improvement. Another thing that I was able to determine from the bench measurement using the little filter angle gizmo was how the filters pass some of our wavelengths of interest as the angle increases. Now, for most of the filters that I tested, the response is almost completely flat. So, for example, if we look at the bright pink line on the O3 plot, that's for the NB1. It's one of the Nebula Booster series. It passes O3 at about 94% transmission, all the way up to an angle of 20 degrees, and then it starts to dip down a bit. So that equates to a F ratio of around f1.4. So that filter, you could use it essentially on any optic that you could want, and you will get essentially the same filter performance. Now, there are two the two with the narrowest band passes, the NBX and the NBZ, are essentially the same filter. They do start to tail off. O3 starts to drop after F2 or around 14 degrees angle. And H alpha, it's more around 12 degrees. They start to roll off. So even at F2, you're probably not going to notice any reduction in performance from those filters at that speed. Now, if you have something faster than F2, like maybe a very expensive camera lens or something like that, then you are going to see quite a drop off in performance of the NBX or the NBZ. However, EDAS does sell a new NBX called the ultra high speed, which is designed to work in that pocket, sort of between F2 and F1.4. So that was all based on bench test data. Now, I also, as the weather permitted, took some pictures using all of the filters under test. And when I did the testing, I tried to do it in a controlled way that allowed me to compare both the impact of the filter on the contrast in the image, but also on how long it took to get the image. So this is a bit of a summary table of the data gathering with the sub-exposure times noted sort of in the one column. I varied the sub-exposure to get roughly the same brightness of sub, but then stacked for 5 minutes. They're all 5-minute stacks, regardless of the sub-exposure time. Now, from those base images, I was able to pull out the histograms for each channel, red, green, blue, and determine how much of a reduction in the location of the peak in the histogram there was in each color channel compared to the no filter case. And when you take a weighted average of those, you get a similar number for the luminosity channel. And those compare actually quite well to what I calculated from the measured spectrums. So I was pretty happy with that there was consistency between the bench test and the field test. So that kind of hidden in this is one of the costs of using a filter. So for example, the top row, the EAO1 filter, which apparently ZWO had EDAS make for them especially for EAA, electronically assisted observing, I think is what EAO stands for. So anyway, that particular filter only passes about 20% of the light that comes into it. So that means compared to no filter, you would expect to need about 5 times the exposure. Similarly, the NBZ, which is quite a bit narrower pass bands, they're about 12 nanometers wide. It's only passing about 6.4% of the light that's coming in. So your exposure time is going to be, that much longer than if you had no filter. So one of the trickiest parts of my testing was figuring out how to white balance and stretch each image in exactly the same way so that you could do a visual comparison. It took a little bit of figuring, but I think I've kind of figured out how to do it. Anyway, this first batch of images are mostly the LPS type filters, plus the EAO1 compared to no filter. The improvement in contrast is pretty subtle. Probably the EAO1 results in the biggest improvement in contrast. Mostly if you look at the faint nebulosity sort of in this area here and down around the bottom here. Compare that in all the images. And that's consistent with what I predicted. So the narrower the bandpass, the better the improvement in contrast. Now, one interesting thing to note is the visibility of the running man up here. So probably it is really hard to tell probably on your monitor, but there is a subtle improvement in the visibility of the reflection part of the running man in these filters. It's subtle, but there is a small improvement. If I had taken longer than 5-minute exposure and stretched the image more, it probably would be more evident. Now, if we scroll on down to the NB series filters. So here, the improvement in contrast is a bit more noticeable, with a gradual increase as you go from the NB1 up to the NBX and NBZ. But I don't know if you can tell, but as the filter bandpass gets narrower, the amount of reflection nebula they see gets less and less, to the point where you basically can't see any reflection nebula anymore in the NBX and NBZ. That's sort of the trade-off for the higher contrast on the nebulosity, is you can't see the reflection nebula anymore. Now, you might be wondering why the NB3 looks so bizarre. And it's because it has two pass bands, one at O3, which explains the greenish color, and the other is at sulfur 2. So with no H alpha in the image, it makes the O3 component quite dominant in the image of M22. It makes it look kind of bizarre. So I, for the first time, tried my hand at doing a Hubble palette using I extracted the O3 and sulfur 2 from the NB3 image and the H alpha from the NB2 image. And I ended up with this, which is pretty noisy, but it kind of gives you the idea. So that was the extent of the imaging. But the final thing that I looked at was the idea of white balance. Now, the basic gist of the bench testing and the imaging testing is that the LPS series of filters don't really do much to reduce light pollution. They do quite little. But that is counter to what a lot of users say. A lot of people use those filters and they like them a lot. They find that they generate a very pleasing, well white balanced image. And so I dug into this a bit more, and what I sort of figured out was it isn't that the filters are blocking light pollution to improve contrast. They're blocking light pollution to improve the white balance. I tried to sort of reproduce that using this simple color bar scheme. So the image on the top left is the basic color bar. The top middle image is my simulation of the color of the light pollution in my backyard. It's predominantly sodium and mercury vapor lighting with some LED thrown in there and some incandescent lights thrown in. So it's a bit of a orangish, brownish red tint. So I added that in an image editing software on top of the color bars to get the image on the upper right. So you can see that the colors are changed, and also the contrast is affected. Now, if I, after the fact, try to white balance that image just by adjusting each histogram for each individual color channel, I get the image on the lower left. You know, it's not quite the same as the original image. There's a loss of contrast, and some of the colors still aren't quite right. You know, the black square still has a bit of a hue to it. And that's sort of what you would get if you tried to image, say, a galaxy under light polluted skies. And then after the fact, just tried to white balance the image in your image editing software. The colors are just don't look quite right, and your contrast is affected. At least what you're perceiving as contrast between the colors is affected. And so just as an experiment, I used my Canon mirrorless camera to look at the image in the upper right on my computer screen, and I took a picture of it, and I got there that lower central image. And then I took another image of the same thing, but with an LPS P2 filter added to the front of my camera lens. And I got the image on the lower right. Now, to me, and it's not the most controlled experiment, but to me, the image labeled F here, the lower right, is a closer match to the original one in the upper left. And that sort of is the gist of why these filters are liked so much. It's, I think, to do with the fact that they can correct the color of the image that is shifted because of light pollution. You're not dramatically improving the contrast of the object, you're just improving the color balance. Anyway, that's sort of the outcome of my testing. So that's about it on the EDIS filters. If anybody has any questions.
Fantastic stuff. We are so honored and privileged that you are presenting this to us, and we're excited. Does anybody have any quick questions? We still have 2 or 3 guys we want to get to with the first round of images, but if we just did a couple of questions quickly, who would have one?
Yeah, I got certainly one. So you mentioned you use the Optilong Extreme, which is a filter that I've been playing around with for the last couple of months. How do you find that compares to the IDAS series that you discussed in the paper?
So I like the Extreme. It has, I think they're around 7 nanometer wide band passes. It does have an issue if you try to use it on fast optics, but that's not an issue for me. I'm usually around f6 all the time, so it's not a big deal. But yeah, I like it. It produces a good contrast. The images are easy to color balance, because I found in all of these multi-band or dual band pass filters I've tested pretty much all of them. If the 2 bands are different widths, it causes problems when you try to white balance. So if anybody has an L Enhance, which came out before the L Extreme, the L Enhance is a problem to white balance because the green band is almost twice as wide as the red band. So it's letting in so much more green light that you're now having to correct out. And as a result, you're kind of dampening out what you're trying to actually see that's in that green channel. So the L Extreme, because it has 2 bands of the same width, much easier to white balance. The contrast I find is good, but if you're using it on a fast optics, it's not great.
Maybe one more question.
Yeah, I was going to ask Jim if for different filters, because that's an issue that I notice a lot as well as the color balance of different filters. Which filters that are multi-band do you think have like the best color balance?
When you say multi-band, you mean like the EDIS LPS series ones? So
yeah, I was thinking like, for example, the one that comes with the Celestron Rasa, or that you can get. It doesn't come with it, but it's like,
yeah, you can order it. Yeah,
you're right.
Yeah, so that particular filter is almost identical to the LPS P2, but the P3 is noticeably better. If you want a filter like that for doing color correction, to do like galaxies and reflection nebulae and things with a lot of blue in it, not just emission nebulae, then I would recommend the P3. It seems to be a good filter for that task.
You know, Jim, you helped me a lot just with your very, very simple recommendation that I use the red and the blue correction in the imaging panel on the right-hand side of SharpCap. And I had indeed, just as you predicted, I had never messed with those. So they were defaulting at 50%. And I think you recommended pushing them up to 70. It was an immediate difference in the output. I didn't have that green ghosty tinge anymore with my $650 Celestron light pollution filter on a Rasa 11. And your quick little advice, I think, saved me from all that frustration. Thank you so much.
Oh, you're welcome. Yeah, even if you didn't have a filter on, I would always recommend that before you touch the adjustment in the histogram view, correct those camera gains first. Get close.
So super. Jim, I wish we had more time. We do want to catch two other guys. Do you have anything else that you'd want to say in closing? Because we've really appreciated this. We're so grateful. Anything else?
I'd like to come back if you would add me.
Oh my goodness, we would love to have you. You bring so much wealth of experience and just literally years of extra doing this, what we're doing. So by all means, we would always welcome you back.
Okay, sure.
Okay, super. I want to make sure we give Mike Huerto a chance. Mike Huerto. Mike, are you there?
Yep, I'm here.
Go for it, Mike.
And for those of you not familiar with the Spanish language, huerta means orchard in Spanish. So let me share my screen. It's not my surname. It's my screen name on cloudy nights. Let me just give you a quick introduction to my system, and then I've got a live share I can do as well. Let's see. Can you see that?
Yes.
Okay, so I'm pretty new to astronomy. You can see the PowerPoint. It's flashing on my TV, but
yes,
you can see it.
Mm-hmm.
Yeah. Okay. I'm pretty new to astronomy, and I picked up this third-hand used 14-inch Go-To Dobson just over a year ago. And I was told then it was only good for visual, maybe a few planets. And I've been enjoying sort of pushing the limits on it. It's a fun piece. I've held off buying other scopes, but I'm getting close to buying a refractor. I've got a ATQ5 mount ready to receive something soon. But so this is what I've got at the moment. Tonight I've got the 294. On the scope, there's a coma corrector on it. I've rigged this whole this visual scope up with all the bells and whistles. I've got a nice little remote focuser on it. Latest addition is a Fulcrum rotator in an attempt to get rid of field rotation because it's an Alt AZ. And I've got everything connected remotely into my basement here from outside because it's about 8 degrees centigrade outside. So pretty chilly, and all running via ASCOM. And the SynScan app controls the mount. I use Carte de Sail and SharpCap, obviously. And this is the view from my back door. So quite a nice open view to the north. I've got a big hill in front of me to the south, but still works out quite nice. This is the scope. It's, as you can see, fully kitted out. You can see the shroud here, which I now always pull back, especially for planetary viewing, because I found, especially in the summer, I had a problem with thermal currents, and pulling back the shroud really seems to get rid of that, as judged by diffraction patterns on out of focus images of stars. So works out quite nicely. That's the camera there, the Falcon D rotator. Here's a view of it elevated. So yeah, this is the new Falcon D rotator, the camera, the focuser, and then this is the USB Ethernet extender, which I got the idea of using from the first session of Doug's that I attended about 6 months ago. Was it, Doug?
Yeah, yes.
And I thought, wow, that's a great idea. I found one on the internet for 70 euros, and it works a treat. So I can connect my mount with all the various USB gadgets connected via this Cat7 cable here from the mount direct to my PC, which is now in the basement, which is where I'm speaking from. And touch wood, that works very nicely. No problem. I can run, you know, even though it's only USB 2, it's not a USB 3 system. No problem running 2 cameras from there. No problem with speeds. So really good. And this is how I leave the mount and the telescope outside. I have it covered with it's a motorbike cover, and this is my custom built pallet shelter for it, which works great because what this does is it gets pretty hot here in the summer, so it acts as a shade house and really keeps the temperature down with a little bit of air going through it. The dog guards it, so it works out quite nice. Again, Dobson's are generally thought of as good for visual and planets. I've obviously done quite a few planets, especially this year. You know, Saturn and Jupiter, a little bit of Neptune a few nights ago. Wow. But have done a lot of experimenting on galaxies and nebula. It's the top left there. You can see the Triangulum galaxy. That was a 40-minute run where I was testing the limits of the field rotator to compensate for field rotation, and that worked beautifully. That was some 2,500 or 640 4-second captures for that picture, all stacked live in SharpCap.
That's great.
I did cheat a bit though, because what I did was I took the FITS file afterwards from the SharpCap that I saved, and I processed that in StarTools to really bring out sort of the O3 and the hydrogen colors, and works quite nicely. And that's a standard trick now. You can see got some nice images there of the Lagoon Nebula, the Trifid Nebula. Those two are just 5 minutes, you know, and the rest of these here are just 5 minutes.
That's great.
The Dumbbell Nebula as well was just a 5-minute stack. So the thing's pretty sensitive. It's f4.5, works quite nice.
That aperture is really helping you.
Yeah, no, it's really good. So let me, that's the PowerPoint, switch the stop sharing and show the live stack.
And you're a good sport, Mike, because you've stayed up till 4 a.m. or so to do this, right?
Yeah, if I start jabbering meaninglessly, it's because
you're a good sport.
A little bit, you know, sleepless in Seattle sort of thing, or sleepless in Valencia. So it's not live stacking. This is just at the moment what we see. This is just the recenter button. So on this, the nice thing about this being a go-to job running ASCOM, I can do plate solving everything on it, on this large 14-inch DOB. And as you just saw there, I just recentered it. If I start, let's get rid of that pixel center thing. If I start live stacking, you'll see, let's clear that one. It should start building up pretty quickly.
Nice.
Yeah, so let's do there, and then I can't get the color one from this. Hang on, let me just.
The panel is too short to see the.
Yeah, I'm gonna have
photo.
to go actually in and. Yeah, I can't. Yeah, I can't access that panel control.
You have to raise. Yeah, you have to raise the height of that panel.
And so, like, there we go. There we go.
It's beautiful.
So, yeah, so that's just 22 4-second frames. Obviously, with M42, that's cheating a little bit. But as you can see, it's a nice system. It's, you know, 5 to 10 minutes is generally enough. So it works quite well. Stop sharing. Actually, I'll quickly show you the rotator thing. If it's here, it is. So this is. Can you see the rotator now? This is the rotator control panel.
Mm-hmm.
Yeah, very nice piece of software that comes with it. It shows you either in degrees or in angle, just the graphic, how much it's rotated to keep everything square. You get here the arc seconds per second, and it's really neat as you move from, you know, say due east or west where there's very little field rotation to south or north. We're looking south at the moment, obviously. The field rotation increases, and you can see that number increasing here. The other night I was doing the Triangulum Galaxy, and I actually followed it going over the zenith almost, and the thing went up to about 70. And that was a little bit too much for the field rotator. It couldn't quite catch up with it there. But generally between 0 and 30 arc seconds per second, this device is really excellent. And it's allowed me to really, with this Dobson, this Ultra AZ, capture now the whole field of view.
Wow.
The only thing I'm challenged with now, and I'm trying to figure out, and maybe hope to get some advice tonight from you guys, is the tracking on this mount is very poor. I generally have to, I'll switch the live stacking off. I generally have to recenter every minute in order to, you know, keep the frame in the image. And what I wanted to do was do a sequencer to recenter every minute using plate solving.
Mm-hmm.
But that hasn't worked as of yet. I'm running into a problem with it sort of stalling as it tries to plate solve in sequencer. So I don't know if anyone else has had experience with that.
We do have some guys that have worked on that sequencer. Anybody want to offer any advice to Mike for that?
Unfortunately, I mean, I've used sequencer, but unfortunately not for plate solving. I tend to do my plate solving manually, so I can't really offer much.
Yeah, that's
I
kind of how
have a
I'm doing
question.
at the moment. I either nudge the thing or plate solve manually.
You're stretching us.
I have a question about your tracking. That's a Skywatcher, right?
Correct.
And does it have the ability to have auto guiding?
Excellent question. At the moment, no. And do you know why that is? Because the SynScan app ignores movements in the reverse direction. So it means in SharpCap, I can't go through the calibration stage because it won't calibrate in the reverse direction in DEC or RA, and in Fire Capture Auto Guide, it's the same thing. It won't move it in the reverse direction. I got that information directly from the Skywatcher engineers via their UK distributor I've been communicating with.
Interesting.
And I'm talking both with Torsten for Fire Capture and Robin for SharpCap to solve that problem
Wow.
to circumvent that. Torsten's idea is to send a 0 degree move or pulse guide to the mount before it tries to move it, so the scope won't think it's moving in reverse. And Robin's solution is to try and lower the tracking rate. Okay, so that it's ahead of it.
Very
So
innovative.
I'll be trying both of those next week on planets, at least anyway, to see what happens. But that, if I can solve that, at least for the planets and features, that would be a game changer for me. But
Right, this is great. I do want to respect the folks that, you know, counted on us stopping on time. So if you don't mind, to go ahead and drop.
yeah,
your
sorry, go
screen.
ahead. I've taken up more than my share. Thank you very much.
No, you've done fine. I just want to make sure that we follow that. I did want to thank you, by the way, Mike, for being so patient with 4 a.m. In the night. It's really cool that you hung in there with us and even did live views. So thank you very much for being a good sport.
It's a pleasure. It's been a pleasure. And Doug, thanks again for organizing this.
Oh,
Really
no.
is tremendous.
Thank you. And Mike, I think if you put that thread on the EAA forum on Cloudy Nights, we'll jump on there with you with this question. So don't give up the ship on that. I do want to mention that Wayne Zool was with us, but I think he's dropped off. And also we had Rol. You guys remember him from over in, where's Rol again? He's in Belgium, right? We had those two guys. Now, I don't think we gave time for Jason Cropper. He wasn't around when we called, and Dave Elder, and both those guys have dropped off. But Lance and Jonathan and Dan, we at least want to say hi to you. Lance, you want to say hello to the group? Got a mic there, and I see you're still on, but if you got a mic, you can unmute. Maybe Lance had to step away, left his connection live. And then Jonathan, I think you came back, and I think you even messaged me. You want to say hello to the group, Jonathan?
Hey guys, how's everyone doing?
Did you have an image tonight?
I
Jonathan?
can if everybody wants to see it. I've got a NGC 891 up on.
Why don't you throw it up there real quick? Because you've been so patient as well, Jonathan.
Let me just flip over to. I've got it on my iPad. So let's see. Share screen. Let's see. Should see it in just a second here. All right. All right. So this thing's been stacking for well over an hour now, but
oh wow. Is that 104?
It's 891 NGC 891. It's an
891,
Andromeda. It's actually one of the November. It's on the November list, observing list on the EAA forum. Yeah, observing challenge. I can think of the word. I'm shooting this with my Hyperstar on my Celestron Nexstar 6 SE. I do have an L Pro filter in here, and it's what else was I going to say? I'm using a ASI 183 MC Pro.
You're going to have to put that on the images that you gathered, because that is a neat image of that dim of a NGC object. That's difficult.
Yeah. I mean, it's amazing with just and I'm in a probably Bortle 6 or 7 here in kind of the southeast side of Phoenix, and we got pretty good scene out there tonight and everything. But
6-inch scope, that's amazing.
Yeah, just a simple 6-inch. It was a Christmas gift last Christmas. So
that's tremendous, Jonathan. Thanks for sticking around. And then we wanted to ask Don.
I can share.
I think Don, you said that your image had dropped. I think. You still with us, Don? Yeah, he's there, but he's not unmuting, so maybe he's had to step away. Okay, I think that means that we've all come around at least once. I apologize tonight. We didn't get to go around for a second round, and I think that's a byproduct of a couple of things. First of all, of course, because we have such a good group tonight, good, strong showing, Eastern time zone, North America. but also I think also because of our special speaker. And one more time, Jim, we're glad for the fact to have heard from you. We will meet again, of course, next time. We'll find that new moon Saturday, and we'll try to put together. Anybody else have anything else before we adjourn? We are at 2 hours and 10 minutes, so we want to go pretty quickly. But anybody else have anything else before we go?
I was just gonna, I know, and Jim, if you don't mind real quick, I just IM'd you, but like the L Extreme with the I was really looking at that one, but you were saying like with the Hyperstar, that's probably not a good combination because of the speed of the optics.
No, the EDAS NBZ would be the filter you would want.
Which one was that?
The NBZ.
The NBZ. Okay.
NBZ.
NBZ.
In the United States English is NBZ. Yeah.
Gotcha. Thank you.
Is that English you guys speak then?
And Jim,
No, but
since it's a real honor to have you here, and thanks for that. I'm gonna have to look up that publication you presented. Is that on your thread on the Cloudy Nights?
It is.
Yeah. Yeah, there's a link to it.
Take a look at that. That's some great science. Good job there. And can I ask as well? I've been looking at something like the L Extreme. You saw my setup. Is that something you think would work well? I'm sort of Bortle 5, you know.
And you're f4.5, you said?
Yeah. What would you recommend?
Let me that image here. I can share.
This is great having an expert on tap for this.
This is a rare privilege.
Fantastic.
It just happens that between me and you guys, Optolong read the paper that I wrote on the L Extreme. So there is another test report on the L Extreme on my website. They saw it. I guess people told them about it, and they were pleased by it. So they sent me a new filter called the L Extreme F2 to test.
Oh wow!
These are some of the results from just this week that I did this measurement. So this is the transmissivity of O3 and H alpha as you increase the angle of the filter to the light. And you can see the L Extreme is the green line, how it falls off. Mm-hmm. So your, O3 is about 50% transmission at F2, and H alpha is, it's only at 10%. So not great.
So don't buy that new filter.
Yeah. So you could go buy the new L Extreme F2. The only thing is it's only good at F2. If you see the blue line, it has a hump that's centered kind of around maybe 2.3 or so. Mm. So if you wanted to use that filter at F6 or F5, it's not going to work very well.
But it's bad on O3, you're saying?
O3 is okay, but yeah, I don't know if you could.
Oh, I see.
Because compare the green line to the blue line. See. So the green line is the L Extreme. The blue line is their new filter, where they've shifted the bands. So what happens when you angle the filter? You're essentially making the layers on the filter thicker. Oh. The light's having to pass through more of the layer because it's going at an angle, and that shifts the bands down in wavelength.
Wow.
So Jim, interpreting this, it looks like for mine, the yellow, the EDAS MBZ would be the best. Is that correct?
Yes, I would think so. If you're around F4, I'd say that's probably your best bet.
What great information.
Fantastic, Jim. Thanks. Anyone else before we go? I appreciate you guys putting up with us running a little overtime here, but all right. Well, why don't we close out? And just want to thank everybody that stuck with us. If you're watching this on on YouTube and you've stuck with us this far, thanks to you for watching this recorded. And for all the rest of you guys, we'll look forward to seeing you on Cloudy Nights Forum. All of us are on the Cloudy Nights EAA Forum. So again, if you're watching this on YouTube, we'd invite you to come and join us there. And we'll see you next month. So everybody, thanks a lot for being a part of this.
Thanks again, Doug.
I think next time, aren't we, Kim, focused on Australia, I think next time?
Yeah, sure. Sounds like a great idea.
Yeah. All right.
Cheers.
All right. We'll see you next time, guys. Take care. Good night.
Here's everyone.
Bye, guys.
Good night.
Good morning.